Yes.
All right. Have you done the homework?
Yes, sir.
All right. Any doubts? Rahman, Mazia, Peer, any doubts from NCRT or from anywhere else? Okay, then write down the question then. All right. A few things are left in this chapter 3D. After that, we are starting probability today. All right, let's start with the question. Three vertices of a parallelogram. Three vertices of a parallelogram are A is 3, minus 1, 2. B is 1, 2, minus 4. And C is minus 1, 1, 2. Find the coordinates of the fourth vertex. All right, try to solve this question. I'll give you a few minutes. Yes, Rahman, you said anything?
Yes, sir. Can we find out why like object like are equal? So can we point?
Rahman, your voice is not clear. It's breaking. Can you speak a bit louder? See, in here you can use the properties of parallelogram, right? Absolutely right, Rahman. You can find by midpoint formula. That is the only good way to solve, right? Otherwise, you would be solving equations, and that would be too much. All right. We know that the bisector, sorry, the diagonals bisect each other. So midpoint of A and C is same as B and D. That way you can find the fourth vertex. Mazia, you have to find the vertex D, all right, not the midpoint. Yes, Mazia, it's absolutely correct. The midpoint is 1, 0, 2. Okay, anyone has the answers? Mazia, Rahman, Alvia, Peer. Rahman, that is the midpoint, right? Let's assume the coordinate for D is x, y, z. All right. And let this point be O. So What would be the x coordinate of O? X coordinate of O will be, let's call this OX. X will be 3 minus 1 upon 2, and that is 1. OY will be minus 1 plus 1 by 2, that is 0. OZ will be 2 plus 2 by 2, and that is 2. So we got O as 1, 0, 2. Now we know that midpoint of B and D will be same, will be O. So we can write OX is equals to x plus 1 upon 2, and this is equals to 1. So x is equals to 1. All right. Same way we can write OY is equals to y plus 2 upon 2, that is equals to 0. This implies y is minus 2. And OZ will be, Z coordinate is minus 4. So Z minus 4 upon 2 will be equals to 2. So this implies Z is equals to 8. So the fourth coordinate D is 1, minus 2 and 8. Is it clear, everyone? Rahman, clear? You have to find the, all right, Rahman, see. The midpoint of A and C is O, and same for B and D. I assume the coordinate for D is x, y, z. All right. So I can find the coordinates of O in two ways. Either I find the midpoint of A or C, A and C, or B and D. Right, Rahman? Clear till now? There are two ways to find. Now I know the coordinates of A and C. So I found the coordinates of O first, that is 1, 0, 2. Now to find the values of x, y, and z, I again found the midpoint O by finding the midpoint of B and D. Right? How to do that? X coordinate, add the x coordinates, divide by 2, right? Midpoint formula. And that would be equals to x coordinate of O, that is 1. In this way I can find the value of x. Same way y and z. Clear, Rahman?
Sir, can you show how did you find for Z?
Z, all right, this is z coordinate plus z coordinate of B, that is minus 4. You add them, so this is minus 4, so z minus 4 by 2 is equals to this value, 2, z coordinate of O, right? So 2 into 2, 4, plus 4, 8. All right, this is z plus 2 by 2. Clear, Rahman?
Yes, sir.
All right. Peer, Alvia, Mazia, is it clear? All right. Okay, last topic of this chapter is write down centroid of a triangle. Okay, if there is a triangle with the coordinates of vertex as x1, y1, and z1, x2, y2, and z2, x3, y3, and z3, then the formula for centroid, suppose the centroid is O, all right, Then OX you can find by x1 plus x2 plus x3 by 3. OY will be y1 plus y2 plus y3 by 3. OZ will be z1 plus z2 plus z3 by 3. Right? Write it down. This is very simple formula. All right. Let's solve a question for this. The centroid of a triangle ABC is at the point 1, 1, 1. If the coordinates of A and B are 3, -5 and 7 and -1, 7 and -6 respectively,
Sir, can you scroll up for a second?
scroll up. Is it okay, Rahman?
Sir, a bit up.
You need to see the previous question.
Yes.
All right. All right.
Okay, sir. Done.
Okay. Respectively, find the coordinates of the point C. All right, very easy question. Try this one. 2-3 minutes maximum calculation. Anyone solved it? Rahman, Mazia, Alvia, Peer? One minute. All right. Rahman, I don't have the answer. All right. Let's check it. If that is the correct answer. All right. So centroid x coordinate is 1, and this will be equals to 3 minus 1 plus x upon 3, right? So this is 2. So the coordinate of x is 1. Cy is 1, and this will be equals to minus 5 plus 7 plus y upon 3. So 2, this is also 1, 3, yes, 1. Z will be equals to 1, and this is equals to 7 minus 6 plus z upon 3, and this is equals to 2. So the answer is 1 comma 1 comma 2. Absolutely right, Rahman. Peer, is it clear? Okay, Mazia Alpia. Which one in fraction? Peer? No, no, same process, right? This is the z coordinate for the centroid. This is the formula, right? Z coordinate of A, Z coordinate of B, Z coordinate of C by 3. Just cross multiply and find the value outside. All right. So C will be 1 comma 1 comma 2. All right. So this chapter is finished. Do you have any doubts from this chapter? Any doubts at all? Rahman, Peer, Mazia, Alvia, any doubts from? All right. Okay. Next chapter is probability. All right. Rahman, what do you know about probability? What is probability?
The events, the possible events.
Possible events. All right. So somehow two possible events, but we try to calculate the occurrence, right? What is the chance of occurrence of this possible events, right? This you have studied till class 10th. In 11th, we are trying to study from the uh, basics, all right, how it was invented in that way. So we are going to study probability in relation to set theory, all right? If there are many elements, how to calculate probability like that. All right, and we'll see how we got the answers in class 10th, 9th, and 8th, and so on. All right, so first write down what is probability. Probability is the probability means possibility. First thing is this, right? In mathematics, at least, it is a branch of mathematics that deals with the occurrence of a random event. This is very important, right? A random event. The value is expressed from 0 to 1. All right. So probability we use in any random event. Now, what is a random event? For any random event has to have two conditions. All right, it has to satisfy two conditions. First condition is there should be more one outcomes of that experiment. All right, it doesn't has to be like only one result. It has to be have many results, right? Second condition would be you cannot decide what is the result going to be. Suppose you are experimenting something in chemistry, right? You are adding two hydrogen atoms plus one oxygen atoms and something, and you are creating water. There is only one result, and you already know what you're going to find from that. So this cannot be a random event. All right. Random event is something that if you do this again, 2h plus o, you should not be knowing what you are going to find out. All right, that is what random event is. One thing more, you know the set of values, all right, that you are going to find. You are, if you are tossing a coin, you know you are going to either get heads or tails, right? But you don't know exactly what you are going to get. So you know the set of results, but you don't know the specific result in each experiment. Is it clear what a random event is? Rahman, Peer, Mazia? All right, write it down. Okay, write it down. An experiment is called random experiment or random event if it satisfies the following two conditions. It has more than one possible outcomes. It is not possible to predict the outcome in advance. All right, note it down. All right, now write down outcome and sample space. What we call an outcome and sample space. A possible result of a random experiment. A possible result of a random experiment is called its outcome. The set of all possible outcomes of a random experiment is called the sample space. It is denoted by capital S. Each element of the sample space is called sample point. Alright, so if you toss a coin, the sample space will be heads and tails. These are the sample points, each element. Alright, note it down. Try this one question. Two coins are tossed once. Find the sample space. Alright, try this one out. You have to find the sample space. Two coins are tossed. All right. What will be the answer here? If you toss two coins, then you can get either heads, head tails, tail heads, or tails. So this will be the sample space for this question or this experiment. Clear, everyone? Peer? Okay, I hope it's clear. Next question. Find the sample space associated with the experiment of rolling a pair of dice. All right, 2 minutes for this also. Right, I'm on 36 outcomes. Peer, Mazia, have you solved this? Albia? Okay, let's see. All right, Peer. This is very simple to calculate also, Peer. See, you can get one in the first die, one in the second, one in the first die, two in the second, one in the third, first, three in the second, and so on till 1 comma 6. So 6 elements for one in the first die, same for second, 2 1 2 2 2 3 like that, 2 comma 6, and this will go on for 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 6. Right? These are the all the elements. Okay, let's try another question. And this is very important to know how to calculate sample space. There will be questions based on this only. A coin is tossed. If it shows head, we draw a ball from a bag consisting of 3 blue and 4 white balls If it shows tail, we throw a die. Describe the sample space for this. Now let's try to think about this and try to write the sample space. All right, what it would be. Peer, are you getting one element only? See, think about it like this. If you get heads, then what happens? And if you get tails, then what happens? Well, let's see, in the previous question, we did only that. If I get one, then what are the possible events after that? We can get 1, 2, 1, 3, 1, 4, and so that. So in here also, if you get heads, then what can happen? If you get tail, then what can happen? All right, try to think it. All right, let's see. Here you are getting 13 elements. All right. See, in that box, we have 3 blue and 4 white balls. So let's name them P1, P2, P3, and W1, W2, W3, and W4. All right. So if you get a heads, then you draw a ball. So if you get heads, then you draw a ball, you can get P1. If you draw heads, you can get B2, B3, W1, W2 till W4, right? These are the all the possible outcomes for heads. But if you get tails, you throw a die. So you can get 1 on the die, 2 on the die, 3 on the die, 4, 5, and 6. So in total, we have 7 elements, and this is the sample space. Clear, everyone? Okay. Write down events. No, we don't have to add right now, Peer. All right. We are just trying to write down all the outcomes in the sample space. All right. We are trying to create the sample spaces. That what are the elements that we can get. All right. Yes, when you need to calculate the probability, we'll be adding them if we need the numbers, right? But that is for later on. All right. Now events. Any subset of a sample space is called event. All right. If the sample space is suppose take that example, 2 coins, heads, 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 tails, tail, heads, and tail, tails. So event can be any subset. All right, subset. I hope you remember from sets. You can take these two, these three, or these two, any. All right. Suppose I say event is 2 tails, then E will be TT only one element, right? One sample point. Clear? If you take event as 1 tail, then event will be HT or TH. So you have 2 elements here. So event is any subset of this set sample space. All right. Note it down. All right. Types of events. What are the different types of events in probability? First type is impossible or and sure event. The empty set phi is called impossible event. All right. For an example, getting an 8 in a throw of dice, right? There will be no element from sample space that you can take, right? So the event will be a empty set phi, that is an impossible event. So what is sure event? The complete sample space is called sure event. All right. If you take all the elements in the sample space, right, the whole set, the complete sample space, that will be a sure event, right? At least one element will be there. So if the sample space is heads and tails, so tossing a coin, and the event is also either getting a heads or tails, then the probability will be 1, right? That is sure event. You can write also, for sure event, probability of that event is 1. For impossible event, probability is 0. All right, note it down. All right. Write down simple events. Another type is simple event and compound events. If an event E has only one sample point, of a sample space, it is called a simple or elementary event. For an example, same example, let's take if you had heads, heads, tail heads, head tails, and tail tails, and the event is two tails, then it will have only one simple point, right? One sample point from this sample space S. So this E will be a simple event. So what will be a compound event? Compound event is if an event has more than one sample point, it is called a compound event, right? Take the same example. You have heads, heads, head tails, tail tails, event P, one tail. So it will have TH and ST. This will be a compound event. All right, write it down.
Sir, can you scroll up?
Is it okay, Raman?
Yes, sir.
All right. I know this is a bit theoretical, but this is very necessary, right, to understand the rest of the chapter. Today it is going to be a bit theoretical class, but from the next class, we'll be solving questions, a lot of questions. All right, done.
No, sir.
All right. All right. So this is all about events. Now, few things we do with events. Algebra of events. Complementary event. This is very important. What is complementary event? Write it down first. For every event A, there corresponds another event A dash called the complementary event to A. It is also called the event not A. All right. So for every event, all right, in this world, if you throw a coin and you get heads or tails, suppose the event is getting a head. All right, and this will be H. Let's call this A. All right. So if you don't get H, then what would occur? You will get tails. That would be called A dash or A complement or not A. So whatever remains except this is A dash. All right. For another example, if you throw a dice, so 1, 2, 3, 4, 5, 6, you can get. All right. And let's call this event A as 1 and 2. You want only 1 and 2. So A dash will be everything except these two. So 3, 4, 5, and 6. All right. You just don't want A 1, 1, 2. So not A, not 1 or 2. So what remains? 3, 4, 5, 6. All right. This is called complementary event. All right. Note it down. We can also write A dash as sample space minus A. This is difference of sets. All right. All right, note it down. Let's try to solve a question. Consider the experiment of rolling a dice. Let A be the event, getting a prime number. B be the event, getting an odd number. Write the sets representing the event. A or B, A and B, A but not B, not A. Alright, so this or means, if you remember, this is union. A union B, this is A intersection B, this is A minus B, and not A is complementary of A. Alright, so first try to write the sets A and B, then calculate these things. Alright, easy question, try to solve. Solved it? Peer, Rahman, Mazia. Peer, have you solved it? No. All right. See, Peer, can you tell me what is set A here? If I write set A, set A is getting a prime number when you roll a dice. So what are the elements here? Rahman, can you tell me what are the elements in A? 2, 3, 5. Absolutely right. And set B, getting a odd number. Odd number is 1, 3, and 5. Right. So now we have set A and set B. What does A or means? A union B, and B, you remember how to find union, right? Just take all the common elements and then all the elements. So this is equals to, first take common elements 3 and 5. Now whatever is remaining, here 2 is remaining, here 1 is remaining, right? Put everything in a single bag. So 1, 2, 3, 5. A union B. A intersection B, that is A and B. We'll be taking the common elements only. So 3 and 5. A but not B. So A minus B. Remove all the elements from A that is in B. So 3 and 5 is removed. So only 2. And fourth one, not A. So A complement. So if A had 2, 3, 5, so in A dash will be 1, 4, and 6. All right. Peer, Rahman, Mazia, clear? Okay, note it down.
Sir, how did we get 1, 3, 5?
Odd numbers, right? Set B is getting an odd number. So odd numbers are 1, 3, and 5 out of 1 to 6, right?
So how are we getting like 1, 4, 6?
In here, see, you only look at the set A. Set A is 2, 3, and 5, right? And sample space of rolling a dice is 1, 2, 3, 4, 5, 6. So I told just before this that A complement is remove A, all right, from sample space, whatever remains will be A dash. So out of this 6, if you remove 2, 3, 5, what remains is 1, 4, 6. All right.
Sir, but they have asked about the odd and prime numbers.
I'm sorry, can you ask again?
Sir, they have asked about odd and prime numbers. So why are we taking other numbers?
No, see, A dash only depends on A, not B. All right, see, if you go back, see, A dash is sample space minus A, right? It doesn't depend on any other thing. All right. If you remember complementary set, if you remember this chapter sets, complementary set is same as here. If you suppose you have a shop, all right, and you sell uh, pizza, burger, and take any dessert, all right, brownies, pizza, burger, and brownies. So if suppose Peer likes pizza, then what does Peer not like? Brownies and burgers. So if set A is 235, then not A will be 146. Whatever is not A will be there, right? So what is not in A? 1 is not in A, 4 is not in A, 6 is not in A. Is it clear, Ramon?
Yes, sir. Yes.
All right. Peer, okay. Mazia, clear? Note it down. Okay. Right. Mutually exclusive events. Mutually exclusive events. Two events are said to be mutually exclusive if they cannot occur simultaneously. All right. You cannot get heads and tails in the same experiment. You can get either heads or tails. All right. So here A intersection B will be equals to 5. There will be no common elements between these two. If this happens, the other cannot happen. If the other happens, this cannot happen. They are called mutually exclusive events. All right. In the case of heads and tails, if A is heads and B is tails, then they are mutually exclusive. All right. In the case of rolling a dice, if you take A as even numbers and B as odd numbers, then they are also mutually exclusive. No common elements between them. A intersection B is 0 or 5, right? Also, there is a note. Simple events of a sample space are always mutually exclusive. Right? If you take only one elements of the sample space, then they will be mutually exclusive. Note it down. All right. This is mutually exclusive, that they cannot happen together or simultaneously. Now, exhaustive events. All right. Events are said to be exhaustive if their union is sample space. All right. What does this mean? That if there is an event A with heads, there is an event B with tails. All right. And we are tossing a coin, so the sample space is heads or tails. Now, if you take A union B, you are getting heads and tails. So this whole is the sample space. So whenever you get the union as the total sample space, these are called the exhaustive events. All right. That they make the whole sample space. And this can happen for three events also. Let A, B, and C be three events, and A union B union C is equals to S. That means sample space. Then A, B, and C are called exhaustive events. All right, note it down. All right. One last thing, mutually exclusive and exhaustive events. What happens there? A intersection B should be phi, but A union B should be sample space. All right. So everyone is clear about mutually exclusive events and exhaustive events. Rahman, Peer, Mazia.
Yes, sir.
Okay. So in the next class, we'll be solving a lot of questions. And please revise this. All right. Don't forget these things. And see you in the next class. Have you noted it down? Rahman?
Yes.
All right. Scrolling up. Is it okay, Rahman? And also finish your assignments that we'll be sending today only. And yes, complete the NCRT 3D chapter. The whole chapter is finished. All right, Rahman, done. Rahman, are you done? All right. See you in the next class. All right. Please revise. All right. Take care.